This is a demo of ArduPilot's new filter review tool. So this is for reviewing your filters and setting up your notch tracking and things like that. So hopefully to replace the use of either the Mission Planner's FFT tool or the one in MavExplorer. So first of all, to find it, we're here on fomo.ardupilot.org, and then we're going to go Tools and then Filter Review. So this is the tool here. There's quite a lot going on, so I thought I'd just load a couple of logs and we'd have a look at them. So first of all, you've got to choose a log. I've got one here as an example. So you need to either have the batch logging on, or you can also do the raw sensor logging. So it's exactly the same as the other FFT filter review tools. You just need to enable that logging to get the data here. And if you don't have the data, it should do a little pop-up and tell you, oh, I can't find the data. So first of all, you can see this log. We've got batch logging. You could have raw sensor logging in the log as well. If you have both, you need to select which one you want to use before you load the file. There's some FFT settings. We'll come back to them later. There's a start and end time of the analysis, and then obviously we've already found the choose log button, and then there's a calculate button. So if we change some of the settings lower down, this button will enable, and you have to come up and click it again. So at the top here, we've just got a flight data. So it's just a couple of things from the log: roll, pitch, throttle, and then altitude. And the idea here is that you want to pick a nice stable bit of the flight with not too much going on, so you can get a nice baseline for the noise, and then you can set your filters against that. So obviously being on the ground, we don't want that, and it's on the ground at the end here. So that will just mess up our review, because it'll sort of bias the noise a little bit away from what you actually see in flight. So I'm just going to select this bit at the end here. Looks like quite a smooth section, so we'll just select this bit, and you'll see the start and end time has updated here. And of course I could always also change it in the box here. So we'll just go back to this little flat section, and you'll see the calculate button has now enabled. I'm going to hit calculate, and it's disabled again, which means it's calculated. You might find, by the way, if you've got quite a big log, it does take quite a long time to load. You might get the little pop-up saying, oh, this page is unresponsive. You just have to wait. I'm afraid it will take a little while, and hopefully it will come good and load up in the end. So then this is our FFT. So this is the sort of plot you might be familiar with if you have been using Mission Planner or MavExplorer. There's quite a lot going on here again. It's all in a single plot. So we've got 3 boxes here, which are for the 3 gyro sensors that ArduPilot supports. So first of all, you can see we've got ICM 20602 here. It's connected on SPI, and then that is running at, in this case, 799 Hertz. So we've got a little bit of information about the type of sensor that is attached. You can see we've got a slightly different one here, and then a slightly different one again here. They're all on SPI in this case, and they're logging at slightly different, or rather sampling at slightly different frequencies, which can be interesting later on. And in this case, you'll see, although we have got a second gyro, it's detected it. It's not got any boxes here that I can click, and that's just because that wasn't enabled in the logging mask in this batch logging log. So it wasn't enabled. And then you can see we've got, for the other 2 sensors that were enabled in that logging mask, we've got a pre-filter and a post-filter. So this was using the pre-post logging option. So we've got both. So you can see them plotted here. And what this tool adds that the other tools don't have is that we have this estimated post-filter. So you see I can enable the post filter estimate here. We get lots going on in the graph. So that means that it takes the pre-filter data, it estimates what the filters would do, and then plots that as a result. So you should see, if we turn off gyro 3 here and just look at gyro 1, you should see that the logged post filter and the estimated post filter line up quite well. So in this case, actually, it's not doing a brilliant job, and that's because in this particular log, it's actually the third gyro that's primary. So the third gyro is the one that the vehicle's actually flying on. It's the primary, and we actually only apply the notches to the primary gyro. So you'll see now we're looking at this primary one, it all matches up much better. So the idea of this is that you can do one flight, get your pre-filter data, then you can use this new estimated post filter to tune in your filters, and then you're done. So hopefully just need one flight, and maybe at the end you do a post filter flight just to confirm that it is matching what the estimated filter suggests it should. So that's this. You've got a whole bunch of tick boxes. You can look at just X or just Y or post filter, estimated post filter. There's everything here. One little hidden trick is that you can click on the titles of the boxes here and it'll enable everything in that section. So that's these filter types and as well the gyro, so it'll toggle everything on and off by clicking on the titles here. So you don't have to go and click 9 boxes individually. So the other thing that we get in this little box here is the logging rate. So in this case, this first gyro is logging at just under 2 kilohertz, and the second one is a little bit higher, 2.2 kilohertz. So this is a sort of subsampling of the sample rate down to this logging rate. So that's the rate in which the batch log is logged. They're all coming out blue here. Oh well. Anyway, so in this case, this means that our third gyro actually goes to a higher frequency. So we can see higher frequency on this FFT plot, and that's just because of the Nyquist frequency of the logging rate. So if you've got a faster logging rate, you can look to a higher frequency in your FFT. The other information this gives you is the frequency resolution. So in this case, our resolution is only about 2 hertz and about 2.3 hertz on this faster logging. So that's just a factor of the length of your batches. So if you're doing batch logging, there's a parameter for batch length. So if you're looking at some really low frequency stuff, maybe sub 30 or even sub 50 hertz, you might want to think about increasing the size of your batches in your batch logging, and then you'll get a better frequency resolution, and you'll be able to see these peaks in a little bit more detail. You can see now we've zoomed in, you can really see the steps there in the frequency due to that frequency resolution. And again, because of the different logging rates, each one has got a slightly different frequency resolution. So let's turn a few more things on. So there's also a number of plot options. You can have a linear scale if you like, dB, there's power spectral density. You can sort of pick whatever you prefer. You can have frequency on a log scale or a linear scale. You can plot in hertz or RPM. So maybe you've got something, you know roughly what the RPM is, so you can change the scale here to RPM. Or maybe you've got a peak in your FFT here, and you go, what RPM is that? In this case, it's just over or just under 7,000 RPM. So you might think, what have I got on the vehicle that might be spinning at that speed? We've seen before, for example, cooling fans. You've got an ESC with a powerful cooling fan. You might see that spiking up here in your FFT. So that's useful in some cases. So the other thing you can do is there's the notch tracking, so we can show the notches. So this is where our configured notches are set up. So you'll see this solid line here is the mean, so that's where the notch is mostly, and then the sort of grey box is the range. So in this case, if we come and look here, we've got a static notch and a throttle tracking notch. So because of the throttle tracking, the center point of the notch moves about. So this is where it is on average, and this is the range it moves about in. So you can show those, and there's the second one. Oh, they're both moving, so I think it's throttle and RPM. So here's all the filter configurations. So this is the same parameters you might adjust on your real vehicle. So now instead of doing your pre-FFT flight, changing a parameter and then doing a post-FFT flight to see the result, you can just change the number here. So I might want to, for example, just turn off the notches and set the gyro filter to 50 hertz, say. So because we've changed this configuration, we're going to have to go back up here and click the calculate button. And after a little while, you should see that's now updated. So the first thing you'll notice is the estimated post filter no longer nicely matches the actual post filter, and that's because obviously the post filter from the log is running on the original parameters, and then we've changed the parameters, and you can see the notches are gone there. So we're still picking up these spikes from the pre-filter data. So we can turn those back on, obviously, and play about with these parameters until you get a nice post filter result there. I'll just recalculate that back. Oh, oops. So you can see now the notches are kicking in again, but we're still a little bit higher because of this higher low pass. So that's all your parameters that you'll be familiar with from configuring the notches in ArduPilot. So then we've got a spectrogram. So this is just this FFT data over time. So this FFT data is averaged, so it's an average of the spectrogram. So this shows you the individual time slices, and if we plot out the whole log, you can maybe start to see the peak frequencies moving up and down a little bit, especially when the vehicle lands here. It's quite clear that you see that really drops off. We can change this between the different gyro instances, so you can see there's quite a big difference between gyro 1 and gyro 3. So looking at this, there's lots of blue, low amplitude stuff at high frequency on gyro 1, but gyro 3 is much more noisy at high frequency, so that probably suggests there's some soft mount on the first gyro. Again, we can pick pre-filter, post-filter, estimated post-filter. So you'll see estimated post-filter goes very flat at the bottom here, and that's just because we sort of don't have the real-world noise there. And you can pick the different axes, so X, Y, Z. So maybe there's some spike in one particular axis, and you can sort of focus in on it. And it plots the tracking for us here. So if I zoom right in, you'll see this is where the notches are hitting over time. So you can see the notch setup, or notches are set up such that they track these high frequency or high amplitude peaks here. So that's the spectrogram, and then we've got a little bode plot. So this is what the filters are applying. So if you take your pre-filter data and you multiply it by this amplitude scale, you get this estimated post-filter. So again, this will move about as you change your parameters. And the green solid line and the red one at the bottom here is the sort of average of the transfer function over this whole sample period. And then the sort of shadow here is the range it moves. So you can see, depending on where the throttle is and the RPM tracking, it maybe moves down a little bit or up a little bit. And the key thing this is useful for is to just see how low your phase lag is getting at the worst case. So if you set up some notches and you allow them to track very low, you might find that you're getting really bad phase lag. The worst case, maybe just as you're taking off, if you allow your filters to track too low in the frequency. And again, we've got a gyro instance plot, and that's just because of the sample rate of the gyros. The bode plot looks slightly different unless you've got quite an extreme change in sample rate between your two gyros. They're essentially the same. And then you can plot on a plus minus 180 phase graph. So that would be what we might typically see in literature is this plus minus 180 phase. So that might be a bit more familiar for some. I think it's a bit confusing, so I like this unwrapped version. You should be familiar with these graphs if you've played with our existing filter tool to look at these bode plots. So that's a little whistle-stop tour with this log. So I've also loaded up a couple of other logs I thought we could take a quick look at. So this one is a helicopter, and the nice thing about a helicopter is that it's got one rotor. It's running on a governor at a very fixed RPM, so you can really see we've got a fundamental frequency here, and then we've got loads of harmonics, and then a great big one here. So that's blade passing, and then or rather blade passing lining up with the harmonics of del 1 per rev and things like that. So this gives a really clear example of what it can look like in some vehicles, and really how many harmonics there actually are. It goes right up here. So that's quite an interesting log to look at. Again, we see quite if I turn off the post filter here, we see quite a difference between the different IMUs. So that's partly due to how they're mounted, and partly due to the different sample rates and the different configuration in the sensors themselves. There's the spectrograph, nothing very exciting here because it is just a single, more or less fixed frequency. The spectrograph is not that interesting, right? There's nothing tracking up and down, and again, quite a boring frequency response because it was just fixed frequency fixed RPM because of the governor. You don't need fancy tracking. You can just set a fixed notch. So that's that. We've got. Oh, this is an example using ESC feedback. So this actually isn't a sort of filter setup flight. This is a flying around flight. So there's not a lovely smooth bit, but it's still quite interesting to look at. So you'll see, actually we hardly see any peaks in here at all, and that's just because it is, the notches are all moving about so much because it isn't a sort of steady flight with a roughly even throttle. So we see a sort of smoothish graph here. And in fact, that's because all the notches are moving up and down so much. So in this case, it's set up for the notch to track ESC feedback. So it's a quadcopter with the notch tracking ESC feedback. So you'll see we've got our 4 ESC feedback lines here. So we've got the fundamental is in orange down here. And there's the 4 ESCs, and then we've got the second harmonic is in green here. And then in this case, there's also a static setup at the bottom here. And that's the whole thing. So you can really see when it's on the ground and when it's flying here. You can really see the noise. And maybe if we sort of squint a little bit, you can see the tracking lines following that. And then this plot really shows how smoothed out. This is because of the averaging of the FFTs. So the notches move up and down so much that actually on average it looks very smooth, except for the fixed notch. So the fixed notch here, this dotty line here, obviously is in one place, so it is not moved up and down. So that in the average result, you see that one come through quite clearly. And then this is a case where you might be interested in looking at that phase lag. So you can see there's one set of, one batch of log data. You see the lowest frequency is coming right down here, and you might just want to check what your phase lag is in that case, because that could be a limiting factor for your vehicle. So that's that, and these have all been batch logs so far. So I thought I would just show off what a raw sensor log looks like. So there's quite a lot more data in a raw sensor log because it is logging continuously rather than in individual batches. So that is this log. So the first thing you'll notice is that because it is raw sensor and we log in using a float value instead of a fixed integer value, you'll see our amplitude goes much lower, so you can really see the effects at higher frequencies, where in the batch logs you'll see they almost all level out at the end. So we see this leveling out at about minus 100 dB, and you'll see that in all of the logs using batch logging, and that's just because of the int16 we log at. So the data is logged, and then because of the fixed range and it's an integer, there's a minimum noise floor which we get around by using floats in the batch logging. And the other thing you'll notice is we get this beautiful spectrogram. So because we're logging continuously for the whole flight rather than in little batches, you get this lovely spectrogram. So you can really see the notches tracking up and down here. So in this case, we've used a throttle-based notch, and maybe we might want to even have turned on this some more harmonics. You can sort of see them up there. So that is the advantage of batch logging. It does make the logs much bigger, of course. And then this is the bow plot again. So that's a little overview of the new filter tool, and hopefully, in particular, this estimated post-filter functionality should be really useful. Hopefully, it will be one flight to get a sort of picture of the noise on the vehicle, and you can use this tool to set up all your filters, and then just do a second flight to confirm. There should hopefully be no more need for multiple flights tweaking filters. Hopefully just a before and an after, and then you're done. So yeah, please give it a try and tell us how you get on. You'll notice in the top corner here we've got a GitHub link, so if you click on that, you can help me or help us if you want to contribute. It's written in JavaScript, so if you know JavaScript, or if you are better at designing web pages than I am, help will be appreciated. If you find a log that it errors out, or you think it does the wrong thing, you could come over here and open an issue and tell us what you thought should happen, what actually happened, and if you could upload the log as well, and we'll see if we can get it passing and fix up the tool. I would say that it probably will only work on relatively recent versions of ArduPilot. We're not planning to make it work for very old versions. But yeah, hopefully a useful tool, and will allow you to get a bit more insight into what the filters do and set them up more quickly. Thank you.